In this video, let's solve this acceleration time graph problem. We are given this acceleration time graph. And initially, the vehicle is at rest. It accelerates over time, and we need to find the velocity after 10 seconds. If you watched our previous video, you already know our golden rule. When a physics formula multiplies the vertical axis by the horizontal axis, it always translates to the area under the graph. For example, to find distance, we use the classic formula d equals the velocity multiplied by the time. Since velocity is on our vertical axis and time is on our horizontal axis, multiplying them means the distance is represented by the area under that VT graph. Today we are looking at an acceleration time graph, and we want to find the velocity. We're going to use that exact same area rule to solve it instantly. Think about it. We know that acceleration is the change in speed over time. We can rewrite this as v equals the acceleration multiplied by time. Look at this formula. We're multiplying acceleration on the vertical axis, a is on the vertical axis, by time on the horizontal axis. Time is on the horizontal axis. Just like before, because our formula multiplies the two axes, then the speed is represented by the area under that line. Now look at our graph. Since the acceleration starts from the origin and ramps up, the shape under the line forms a perfect triangle. So to find our speed, we just need to calculate the area of the triangle. Let's read the dimensions straight from the graph. Our base along the bottom from 0 to 10 is exactly 10 seconds. And our height at 10 seconds, just look across to the vertical line, is exactly 5 meters per second squared. So this area represents the velocity at 10 seconds. Now we just use the formula for the area of a triangle. Half base times height. Let's plug in our numbers. Area equals half. Base is 10 seconds. Height is 5 meters per second squared. So our final speed is 25 meters per second. So option C is our answer. Because the vehicle started from rest, meaning its initial velocity was 0. So this area is exactly its final speed at 10 seconds. If the initial velocity given was not 0, let's say it was 5 meters per second, then you just add this 25 meters on top of this 5 meters per second, which gives you 30 meters per second. Now, why did so many people choose D, which is 50 meters per second? Well, if they blindly do acceleration times time using the acceleration of 5 meters per second at 10 seconds, they just do 5 multiplied by 10, which equals to 50 meters per second. But this formula only works if the acceleration is constant, meaning the graph has to be a flat line, and the area under it have to be a giant rectangle. So a rectangle is literally doubles the area of our triangle. So taking half of that rectangle, which is our triangle, gives us exactly 25 meters per second. So whether it's finding distance from a velocity time graph or finding velocity from acceleration time graph, the golden rule is always the same. If the formula multiplies the axis, find the area of the shape under the line. If you missed that velocity time graph video, click right here to watch it next. And I will see you there.